definitely need to record this. Someone remind me what kind of test that we did last time about one population mean? Z-test. When do we use Z-test? Because there's another test for one population mean as well. Sigma, right? When you know sigma, you use Z-test. If you don't know sigma, you use T-test. So remember the LDL cholesterol last time that we did in adult, and we construct a standardized Z statistic for sample mean, right? Which is using this formula. Which in this formula, we say that a sample mean distribution has a normal distribution, standardized normal distribution 0, 1. Now, the dilemma here is what if we don't know sigma? What if we don't know the population standard deviation? We didn't know sigma, right? Then, well, we don't always know sigma, but we always know what sample standard deviation as, right? So what we can do is instead of replacing divided by sigma divided by square root of n, we're going to replace the sigma with s. Yeah, so this guy right here become s, right, which is right here. So this formula is still the same, but it's going to become x bar minus mu naught divided by s divided by square root of n. By the way, so the z now, it won't be approximately a normal distribution anymore. It has a new distribution. It's called a t-student distribution. So I should say, I should have leave more space here. So it's called t-student distribution, and it's denote t equal x bar minus mu naught divided by, I should have, I'll move these guys down a little bit, divided by s divided by square root of n. And the notation for t distribution, we would say distribution, we would say t parenthesis degree of freedom, or df. Do you remember the notation for distribution of normal distribution is what? N mu comma sigma, right? But for t, it's just t df. Pretty simple. Where df, right there is the degree of freedom. And the degree of freedom is calculated by n minus 1. Very simple. Sample size subtract 1. Right? Okay, so the assumption check for this kind of test statistic is we still have the data still be simple random sample. Again, you don't have to prove this. On the exam, all you have to do is data come from a simple random sample. That's all. Okay. And the second one is the model for the population of all responses. In this case, the LDL cholesterol level, right? It has to be normal as well. Now, what happens if it's not normal? What happens if my population is not normal? Or I don't specify what kind of distribution of my population? Then what will you have to rely on? Central theorem, right? And then central theorem say that what? Then sample mean distribution, right, is approximately normal. Very good. So if sample size large, then the assumption of normality is not as crucial. Now, there's sample size one thing, but what if you don't have this? What if the sample size is small? But if you have the data points, you're allowed to graph it, right? If it's normal, then you're okay. Then you can continue with the T or Z test, depending on whether you know sigma or not. As long as it's normal, then you can continue with your t-test statistic or z-test statistic. Let me remind you about, do you guys remember the standard error that I mentioned about last time? Do you remember that? Anyone remember the standard error? The formula for standard error? Standard error, standard error. That's standard error, right? That's your standard error. If it's sigma, then is what? If it's sigma, then is population standard deviation. If it sigma divided by square root of n is sample standard deviation. We talked about this last time. I don't have enough space. I'm going to say SD, standard deviation. And then if it S divided by square root of n, then it's standard error. And standard error is what? It's the estimation of sample standard deviation. The sample standard deviation is the estimation of sigma. It's like loop within loop. On your assignment for your extra credit, I was asking you to give the interpretation of standard error and standard deviation. Well, I kind of give it to you. All you have to do is plug in the right values. So I know you know which one is I'm talking about. What you see on your assignments. Okay. All right, let's do this one. Put your answer in the chat for me privately. I have like 15 people. Oh my goodness. Let's see how many I have in my class. Participants. It's an important lecture. People decided not to show up. And then they'll email me, what can I do to do better than an exam? I show up to the class. All right, you know what I'm gonna do? For those of you here, on your exam, write pi. I'll give you 3 extra credit points, okay? Write pi on your exam. It's like 14 people here. That's 3 of me here in here. So 7 minus 3 is 14. And this is an important lecture. All right, let's see what you have. Roman, oh no, not Roman. Anthony, 0.86, Larissa, Rami, Tyler, Stephanie, yep. It's about right, right? By the way, standard error of the mean, I'm gonna denote. So let me tell you what I'm gonna denote standard error of the mean. I'll keep the same color so that I'll try. Sometime I can't. I'm gonna denote S dot E standard error, and then parenthesis X bar. This means standard error of the mean. It does not mean multiplication. So equal to S divided by square root of n, and you plug it in. So SE of X bar, kind of like function f of x, right? It does not mean that f times x, right? So this is 27.2 divided by square root of 1000. Yeah, approximately. On the exam, I don't care much about how many decimal place unless I specify how many I want. But a lot of time I kind of look at the people result, and if it's correct math, then I kind of give them full credit. The number is not that I'm looking for. I'm looking for how you present your work. All right. So that's how you calculate standard error. By the way, standard error is the denominator of the t-test, right? T-test. Okay. So typo should be T here, not Z. Sorry, should be T. So again, you use Z-test when maybe I'll write down here. So little note. You use Z-test, maybe a different way around. So sigma, yeah, darn it. No sigma, then you use Z-test. If it unknown sigma, then you use t-test. On the exam, I'm not going to tell you which one you're going to use. But you gotta read the problem, see if sigma is given or not, right? So what is the t distribution? By the way, the guy who come up with this, I think he worked in a brewery at some point, and then for some reason he just named it T students distribution, just to honor students. I forget his name. That's pretty cool. Right. So the t distribution is kind of similar to the normal distribution. It is symmetric. Right? It's unimodal, one peak, and the center is 0. The only thing different is that the t distribution curve is have a fatter tails. Right? They call it heavier tails compared to the normal distribution. So if you look at this picture here, the black one is the normal distribution, and the color one is the t distribution with different sample size. So as you can see, the t distribution have fatter tails. Like instead of flat down to the x-axis, it's kind of a little thicker at the two end. So so what happened is that as the degree of freedom increases, the t distribution gets closer and closer to the normal distribution. You see, red was what? The degree of freedom is 2, and then green is 4, and then you increase to 19 and 29. It's kind of match up with the t distribution, right? Let me ask you a question. Why is the increasing degree of freedom that allow your t distribution to get closer and closer to normal distribution? Go back to the how you calculate degree of freedom. Yeah, more, right? Samples are very important. Do you guys remember the whatever sample distribution mean back then? Right? As sample size increase, your sample mean is get approximately closer and closer to normal distribution. That's CLT. Okay, so how do I calculate the t distribution? How do I, well, you know how when you get z-score, you look up on the table, right? Now for t distribution is a little bit special. You won't be able to pin down the number, but rather a range, which I'm going to show you later. Say, for example, I want to know, I'm so sorry, people on Zoom can't see this. Maybe I'll share. I have time. I'm just gonna chill today. Lecture kind of slowly. Okay. So say if I want to know the degree of freedom, say 18, and then I want to know the value of 1.6. Do you see 1.6 here? Degree of freedom is 18. So that's this column is degree of freedom, 18. And then I calculate my t-test. It's turned out to be 1.6, maybe 1.6 something, 1.6235, maybe. I don't see 1.6 here, right? You don't. But what you can do is what you see what 1.3 and 1.7. Oops, I'm so sorry. Yeah, 1.3, 1.7. So 1.6 is between the two values. And then when you look down, your p-value between what 0.1 and 0.2, between 10% and 20%. So unless you're using software, if you use table, you won't be able to pin down the exact p-values, but you can pin down the range. We'll talk about this later. Do not worry, you get it. Am I still recording? Okay, thank you. I can't see well here. By the way, when you look at the T tables, don't mess up with the Z table. Okay. All right. For one population mean, we're gonna talk about two things: confidence interval and the hypothesis test. So let's go to the confidence interval first. Confidence interval. Remember the confidence interval from last time? We are 90% that the true mean of BMI for all of the US now in 2018 is somewhere between 37.9 and 41.6, right? Now, a lot of people on the exam, not our class, I don't know about you, maybe you're probably gonna make mistakes as well. For my teaching experience, instead of saying we are 90% confident, people will say we are 90% chance, 90% probability, and that's wrong. I'll tell you why it's wrong. Say if I have a 6-sided dice, before I roll the dice, what is the probability I'm gonna get a 4? 1 out of 6, right? Now I'm gonna roll it, and I'm gonna ask you again, what is the probability I'm gonna get the 4 now? After I rolled it. Yep. Well, I don't know. So either I get a 4 or I don't get a 4, right? I don't care about the others. So after you construct the confidence interval, either your true mean is inside the confidence interval or it's not, right? So this is not a chance anymore. It's not a chance anymore. It's rather a probability either 0 or 1, right? So that's why we don't ever use 95 or 90% chance. Yes, I'm pretty sure like the 95% of the time it's true mean is in there, or the other 5%, I don't know, but yeah. Yeah, because once you construct a confidence interval, you should know, right? Either you get the true mean or you don't. Why? Because you given what? Mu naught. Remember you given mu naught. Can someone tell me what's the difference between confidence interval and confidence level?
Confidence level, like the procedure was repeated over and over again, 95% achieved confidence.
Good, right? So if you repeat the process over and over again, say 100 times, then if I do 95%, 95% of 95 of the out of 100 confidence intervals will contain the true mean, right? That's why we don't put the values of confidence interval in the interpretation of confidence level because there's so many of them. Okay? Very good. So make sure you know that. It's gonna be on the exam for sure. So here is the formula for confidence interval for one sample t-test. Again, you don't know sigma, you know which one you should use. Okay, let's do this one. Design of a highway sign. A question of interest is, what is the min maximum distance at which drivers are able to read the sign? A highway safety researcher will take a random sample of 16 drivers and measure the maximum distance in feet at which each can read the sign. So let's answer question by question. What is mu here? Mu means everybody should tell me what mu is. What is that? Population or sample? Population, right? Or true, whatever you want to say it, call it. Population. Population mean distance to read the size for drivers. And then X bar will be sample mean. Maximum distance to be the sample driver. I don't know why I shouldn't just say driver. I don't know why I put a little line there for you. Do you want to continue? This will stop other screen sharing. What does that mean? Yes. Oh, no. Am I still sharing? Okay, good, thank you. All right, so that's step. Number one, you need to verify your assumption. Remember, this is not hypothesis testing, right? We gotta talk about H9 and H8. So number one, verify the assumption, random sample. Again, you don't have to prove this. It should be included in the problem. All you have to write out is data come from a simple random sample. The normal model for the response, maximum distance. Now, question for you. Did I mention in this problem anywhere that my population response is normal, have a normal distribution? No, I don't, right? So you cannot assume that. If I don't, then the next step will be what? CLT. CLT fail as well because what? Well, the good thing is we have data point. You can plot. So that's your last option. If you have data point, you can plot. If you don't have, if I don't give you this, then you stop. Right? Like, Mimi, you don't give me enough information. I cannot move on. But now CLT fell. So good thing with data point, you can plot. Did I admit Rosa already? Okay, let's plot. You know what? I'm gonna share this screen because I have my code here. Sometimes I'm kind of jealous, like, you know, back in the day, they have a lot of technology. Now I have to maneuver between the three. Do you see my R? Thank you. I'll make it bigger for you here. So here's my sign. That's my data set. I'm gonna try the histogram, see if it's normal. Does it look normal to you? No, right? It's left skewed. So maybe some kind of, when you see left skewed, what first thing pop in your mind? What would you think of? Outlier from the left, right? Some guy here very low, kind of drag everybody down. Outlier. So, well, histogram is kind of difficult to see the exact outlier. So I'm gonna try box class. I have one. It looked like somebody below 250. Some value below 250. If I look at my R, this is the only one that below 250, right? 240. So that's my outlier. I'm gonna remove my outlier and I'm gonna name a different data now, new sign. And then I'm gonna do histogram again. Now it look better, isn't it? Right? It's not perfect, but at least it's kind of normal-ish. So you can move on. So you say that is normal. Oh, one more thing. I think the next question asks for sample mean. So I'm just gonna do it right now. So I don't have to switch my screen. Mean is 30. Really? Mean is 30? Let's do it again. Oh, yeah, mean is 497.30 feet. I'm like, wow, that's very close. You're gonna run into the sign. You guys don't see my, did I stop?
Yeah.
Oh, I stopped. Sorry about that. I'll share it again. There you go. Mean is 497.33 feet. I'm gonna do a standard deviation as well, which is 73.43. Now you guys can do this on Google Sheet, right? For Google Sheet, instead of mean, what do you say? Equal average, right? Instead of standard deviation, what do you say? Equal FTDEV. You can do all this in Google Sheet. You can construct a histogram as well. Okay. So sample, so let me say something about the normality here. Use R Studio or Google Sheet to show that data is normally distributed. Well, it's more complicated than this, right? I kind of, well, on the exam, maybe you can explain a bit more. On the exam, you say like, there's no mention about normality in the question. So we're gonna rely on the CLT. However, the sample size 16 is not gonna satisfy the CLT, so we're gonna graph, right? We're gonna graph, and then after the graph, it's not even normal, so you're gonna remove the outlier, and then it's normal. So you can explain a bit more. I don't have enough space here, so I didn't say anything much. X bar is, I forgot what it was, 4497.33. And then it's, I know it doesn't ask for standard deviation, but we need it. By the way, that's the standard deviation of the sample B. Which is 73.43. I would have said approximately, not exactly equal. On your homework, it's gonna ask you a similar question like this. You can use Google Sheet. All right, create 95% confidence interval. Let me remind you the formula that you're gonna use. It's a T confidence interval, right? Because you don't have sigma. So X bar plus or minus T star times SE of X bar. Well, SE of X bar is what? Yeah, standard error, which is S divided by, yeah, divide square of N. I can also denote this as S if I want to. I don't want to write too much. Well, I'm gonna introduce you all kind of notation. So when I say something or write something, at least you understand. Okay, X bar is 49 points. Sorry, 497.33 plus or minus S. Let's do SE first. I'll show you how to look up T star later. So standard deviation is 73.43 divided by square root of N. What N here? Remember, you remove that outlier. Okay, T star. I'll show you how to look up T star. Right, on the third page, on your Moodle table, we do in 95% confidence interval. So you want to look at the 95% column, and then the degree of freedom. What's the degree of freedom here? Sample size 15, so degree of freedom 14, right? So 14, 95, 2.145. That's your T star. 2.145. Oh, yes. Yeah, right. 2.145. Yep. Put the parentheses because do that, and then tell me what you got. QRT. I got 456.66. That's my low bound. Yeah. Is that what you got?
I got that.
And the upper bound.
557.
Yeah. 537.999. So 10. Oop, no. Ooh, my God, 80. 998. We're gonna route it. Write a sentence that interpreted this interval in context. Someone tell me what would you just say out loud? What would you? Actually, how about you guys put it in the chat for me? Put in the chat for me. In context and everything. Like I said, this exam, I'm gonna focus a lot on context because a lot of interpretation. Last exam, I just kind of not look over it. Check, the syllabus, I want to see. Okay, I have a proposal. It seemed like we're gonna finish chapter 20 and chapter 22 faster than we wanted to. So I'm thinking if I have, I'm thinking if I finish chapter 20 before if I finish chapter 20 on Tuesday, but you know, we still have like an hour left. You want to continue on chapter 22 on Tuesday? And then continue chapter 22 and 18 on Thursday, half of it, and then we have like an hour or at least 45 minutes to review. Kind of pushing, you know.
Oh, okay, yeah.
Yeah. Because I'm thinking right now at this rate, we're gonna have like 45 minutes on Thursday, 24. So you want to do that? Just keep going. So we have a like 45 minutes for review. Okay. Hmm? Yeah. Yeah. Quiz is 6. It's not gonna be long. You guys always finish it by 10 minutes. Okay. You want first? Come on. What about the rest? Did you guys type it in?
I just didn't see the numbers. I had the rest of it. Like,
Oh, sorry. Try to practice it right now. Because on the exam, it's gonna be a lot of interpretation and you're gonna be confused. Yeah, walk around, see how you guys do. Yes. On the exam, there'll be a lot of tricky. Yes, a lot. Okay, let me see. Rami, we are 95% confident that the mean, true mean, right? You want to say population mean, yeah. Specify what kind of mean. So true mean or population mean, maximum distance, set. Set, okay, set which driver can read the sign is between good, very good. All you have to do is just put the population mean here. We are not very over that the same thing, Tyler, same. True population, very good. Stephanie, like overkill, like true mean. If you do true, you don't have to use population. Just pick one. But of course, I'm not gonna take points off. Right, very good. Okay. So we are again, do not use chance or probability. Okay, 95%. Maybe I'll give that on like the quiz or something. I'll trick you. I'll give you a bunch of interpretation. You pick the correct one. Okay. We are 95% confident that the true mean or population mean, maximum distance, for which driver can see the sign is between or lie between 456.66 and 538. I should put feet there. Okay, based, if you can say based on the sample size of 15. If you want to, for the last clause, I'm not gonna take point off if you don't have this. Okay, a lot of time I don't even write it. But at least you should have the first one. On the quiz, I can trick you, like, oh, not trick, but I can give you a bunch of confident interval interpretations, say we are 95% probability or 95% chance, right? Instead of true mean, I can change it to sample mean. Okay. Bunch of things I can do. All right, try confident level. Again, I'll walk around, see what happens. See how you guys do. And about the extra credit, don't tell your friend, okay? Because I'm taking your attendance. I know who's here. I'm sorry. 7. Slide 7, if you don't know, go to slide number 7. After this, we're gonna take a break. Well, I'm gonna check the common interval as well. Do you need more times? Okay, so Rami, if the procedure is repeated many times over 95% of the resulting confident intervals, right, would contain the true mean of the maximum is good. It is, put the confident here. If the CI making procedure is repeated many times, okay, we would expect 95% of all. Ooh, no. What about the other 5%? They blind. So be careful. Be careful, Tyler. You meant 95% confident interval.
Yeah.
If we will repeat this experiment many times, 95% of our experiment will result in interval that contain. Okay, make sure you put confident interval here. Stephanie, okay, confident interval here, and then maybe you want to specify your context. Population mean, maximum distance, blah, blah, blah. Good. If the procedure was to repeat it or repeat many times, we expect 95% of the resulting confidence interval plural, sorry, confidence interval would contain the true mean or population mean, maximum distance, which or for which I don't know which one more correct, which driver can see the side. Of course, you have to do the same side, right? 15 people. Side. All right, so that'll be 100%. Whatever you missed, I give like 5 points for each of these. All right, let's check with RStudio and we take a little break. Right here, confidence interval. I'm gonna do two-sided, maybe two-sided. If I do one side, it's an infinite. I think with this try to do two-sided. Right there. So you can see right there. 4, 5, 6. 4, 5, 6.66, yeah, and 5, 9, 5, 3, yeah, exactly, pretty much the same. All right, let's take a 10 minutes break. We come back, we talk about the extra credit assignments. Remind me to record, okay? I'm gonna pause. Typing speed, typing. Right, my Zoomer, we're gonna go to the website called Typing Speed. Click on that. Oh, not Typing Pal, Typing Speed. Yeah, typing test. Typingtest.com. Typingtest.com. Yeah, this one. Thank you. Typingtest.com. I'm sorry. Typingtest.com. And then this one, we're gonna click, leave everything like that. Let's default. I'm gonna start the test, and it's gonna give you 1 minute. And I want you to type as fast as you can and as correct as you can for 1 minute. After 1 minute, I want you to remember how many words you have per minute. Okay, it'll tell you how many words you have per minute. Make sure you remember the value. All right, ready, set, go. Tyler, you wanna use my computer? Here, you can use, yeah. I don't mind. More natural.
Yeah.
Carly, you wanna use this computer? Oh, okay. Oh, okay. No, computer. It's weird. Yeah, that's. Yeah. Oh, okay. Yeah, just take that. You can do two. If it's too slow for you, can do two. I'm gonna do two. I'm type slow.
It's a little bit bad.
Oh my God.
So you were down a line.
Oh my
You're on
God.
the other line, you were typing the below line to the top.
Oh, I
So
did? I typed it
redo
wrong.
it.
Oh, redo. Okay, okay.
Yeah, redo it.
And
just
I got used to the computer. Maybe when Tyler's done. Thank you, Tyler. Oh. And I type slow. I'm probably the outlier.
Yeah, I'm not used to that either.
You, you can try it if you want. You can try one more time here. We'll switch.
Okay.
I'll try here. Test. Oh, come on. Tyler, what happened? Slow something?
Yeah, it was kind of.
Oh, okay, okay. Yeah. More work. All right. Okay, you got done? All right, once you're done, you go to your Moodle. Drag all the way to the active credit assignment and link for typing test. Click on that. And then put in your name and your typing speed. Mine is 40. I'm slow typer. My Zoomers, you guys okay? You guys doing okay there, Roman? You can go to Moodle, and then go all the way down to the extra credit assignment and click on the link to type in test. Oh, Roman already put in there. Thank you, Roman. Let's see who's here. Autumn, you out there? Or you just typing or something? Autumn. Maybe not around. Brendan. Daniel's here. Daniel's here. Larissa. Rosa. Jessica put it in. Larissa put it in. Who else done put it in? Autumn. Autumn. Is Brandon here? No. Daniel. Okay, Autumn, are you doing the typing testing? Because we need the data. Yeah, thank you, Autumn. Yeah. Oh God, we need like half the classes. Not even here. Because we need at least 25. Why? Because I don't know the population for typing test is normal. So at least with 25 you can use CLT, right? Okay, so maybe next class, or you can tell your friend if you know them. Okay, so let me go back to you guys still can see my screen, right? To the extra credit. I'm planning to post a template, but the template does not help much. Maybe I'm doing it right now, so you can see. I'm gonna do it right now. Template. Template. Okay, so I pulled a template for you. I'll talk about it. Okay, so you go here, typing speed right here. So we're gonna talk about one population proportion. It is one sample t-test. I told you in the beginning. So because I don't have sigma, I don't even have true mu. Okay, so for the red line, please fill it in. Right. So what I'm asking you, just fill them in. This hypothesis testing, which we're gonna do next. Importing data into R Commander. This weekend, I'm gonna make a video called R Markdown Basic. For those of you, am I recording? Can't tell. I'm okay, yeah. For those of you using R Markdown, you need to watch the video, just maybe help. If you don't use R Markdown, don't watch it. Okay, it's not gonna help you much. Or you can use Google Sheet. You know how to import data into Google Sheet. Assumption, we talk about this, right? Fill in the red. We also need the assumption response come from a normally distributed. This you have to show me. You have to show me. Now we don't know. Did I mention like population is normally distributed? No, right? I did not know. I don't even know. So we cannot use that. What you can do is you can use CLT. Right? So create QQ plot or histogram. Don't worry about this. You don't know what's a QQ plot. Just create a histogram to see what happened. And then answer a bunch of questions. That's it. Here you can use Google Sheet or R to compute the file number summary. What are the file number summary? Max, min, right? Q1, Q2, median. Then mean is standard deviation, standard error. And here the interpretation. You just have tell me which interpretation of which in the number that you have up here. Right? Generate t-test. Earlier I kind of show you how to do it. I'll show you again using R and Google Sheet during our lecture. What's the distribution of t-test? This is follow. Draw a picture of p-value. You can do it by hand. Evaluate p-value. Just answer a bunch of questions. Now, when you submit to Moodle, I want you to like copy and paste the question. Okay, please do that. So it's easier for me to follow what you're trying to answer instead of like a bunch of line here and then a lot of people they're not even like organized. So please copy and paste these questions. Okay, and then answer maybe in red or in blue, different color. All right. All right, thank you. Okay, so how long do I have? All right, before I continue, I want to talk about interpretation of standard error. I do not have here. I should have it here, but I forgot. Somehow I forgot. I wonder if I can steal a. Okay, here. I'll interpretation of. Forget it. I'm just gonna go to a new one. Here. Sorry, you won't see on the slide. Interpretation of. Let's do standard deviation first. Can someone tell me what is the interpretation of deviation in generically? How come you? I did notice that you guys are dark, and mine's bright. Must be the way around. There you go. Like that. All right. Do you remember? It's on your exam one. So, so what is the word here? Is what?
Well, there's no context.
On average.
On
Right.
average, it would be 2 standard deviation,
And then yeah, and then contacts, right? And then contacts. And then say approximately, right? You have to have the word roughly or approximately, something like that. Oops. And then what? Standard deviation value, right? From the mean of, yeah, of the mean value, right? The mean value. Okay. What about the interpretation of standard error? Is there? No. By the way, see exam 1 is on there. Remember that? Exam 1. Interpretation of standard error. What standard error stand for? What would you use standard error for? What did I say before? What would you use it for? my zoomer? So do you guys want to give it a shot? What do I use standard error for? We estimate the standard deviation, right? Sample standard deviation. So let me say here, we use standard error to estimate, important, estimate sample standard deviation. And then we use sample standard deviation to estimate what population standard deviation, right? So because we estimating, so if we use SE to estimate SD, then the interpretation should look like this. Still on average. Can I use the one that we just did, the maximum distance one? The standard error for, where is it? Or maybe the one that we did up here. Right here. One-way travel time to work. Okay, so I'm gonna use this one, okay? 0.86. Okay, 0.86. Let me see what slide that is so I can tell you what, I can put it on the note. Slide number 3, travel time to work. On average, run out of color. New example. Travel time to work. Slide number 3. One population. Am I sharing now? People from Zoom,
On Zoom, you're sharing. Yeah.
what do you see? Oh, that, okay,
Now I see.
okay, you should see the PowerPoint. All right, people from Zoom, I feel like doing it all over again. But basically, SE is the estimate of SD, right? So all I add here is we estimate that, and the rest will be just like the interpretation of standard deviation. So on average, comma, we estimate that the amount of time that takes 1,000 employee, I believe. Employee to travel to work. You can make your context better than mine, right? To work what is now gonna be blue because no more context, is roughly or approximately how many standard deviation away? 0.86, right? 0.86 in that example. 0.86 minute standard deviation away, I believe. Standard. Give me a second, okay? Give me a second. I want to know the standard deviation, standard error. Give me 1 second. We estimate the average distance of the. No, a little bit different. We estimate that the average time, the average amount. It's approximation of the average amount, the average amount of time that take 1,000 employees, plural, to travel to work is approximately 0.86 minutes. Standard deviation still. Deviation away. I feel like I did something wrong. Minutes away. Away from the mean, from the true mean. From the mean amount. Not true mean, from the mean amount of how many is that? 30.1. Minute. Okay, there will be more. I'll give you more example next time. Today's test is. I'll post this on Moodle as well. Okay. Do you have any questions before I call it a day?
So is the extra credit due next Wednesday?
No. Oh, I'm glad that you talk about that. So let me share screen here, so people from Zoom can see. Right now, your extra credit is due March. Oh, not March 16. That's way too. No. Something wrong. I was talking. I need to talk with you about that because there's one more extra credit coming up. Remember the creative reflection about making
Yeah.
video or poem or comic stuff.
So it says due.
So tell me, what do you want to do?
I feel like because We had an exam the week after
Mhm.
that, and most people are going.
Okay.
For their exams right now.
So we have exam on March. Let's see. Yeah,
Um,
let me pull it up. We'll talk about this. So once and for all, so we can. Syllabus. All right. So because I need to compute your grade and I want you to see it before the final review. I want everybody have the grade on Thursday, April 14th. So that means you have to complete your extra credit assignment sometime before this. Give me a day or two to do that too. So I'm thinking, is that okay if you finish it on
what about
April 7th?
What about 8 this Sunday?
Okay, so between Thursday and Tuesday of April 7 and 12. Okay, so 10, April 10. But for the second extra credit, can you finish like Monday, April
Yeah, I feel
13 or
like-
something like that?
Yeah, like the
Okay,
13th.
okay, so 10 and 13.
That one's not too bad, right? It's kind
No,
of
no.
pretty dull.
No, 13 is too close. I need a day or two to compute your grade.
Our grades do the 14th.
No, I need to show you what you have, so you
Oh,
can calculate your own grade. So
Oh.
you see how much you need for the final. Does that make sense?
Yeah, I'm fine with it.
I need everything to be done by the latest is Tuesday, April 12th.
So could we do this? Could we make the second extra credit 'cause it's easier? Could we make that do the 7th? That Thursday?
Okay, whichever.
Yeah, and then we'll do the 10th for the first extra credit.
How about this? Because it's the second extra credit. And like extra credit is second because it's called creative reflection.
Yeah.
All you learn, what you learn from my class, you put it into wherever you want to do. Extra credit number 2 due April 10th. And then April 7th for, okay, April 10th for both, how's that?
April
You
10th.
figure it out. I don't, you figure it out, April 10th for both, okay?
April 10th for both.
April 10th for both. You figure it out, whatever you want to do first. April 10th for both. Chin right now, so I don't forget.
Yeah, I think that's good.
Okay, April 10th for both. And the people who's not here, too bad for them. You're not here, you lose your chance of input. April, oh, why say April 12?
After our-
Did I mess it up? How come it say April 12 when I saved it? Maximum 30 if you use R. There you go. All right, thank you so much. Have a wonderful weekend and I'll see you next week.
Thank you.
Yeah. Bye. Thank you, bye-bye. Thank you, bye-bye. Bye, guys. Have a good weekend. You too.